All right, while we're oh shoot, I just closed that. Also up on Classroom, I haven't talked about this yet because I didn't want to bombard you with all the information, but this is the last time I'm going to see many of you.
Wait, what do you mean this last time you'll see us?
Until the midterm. If you don't come to the review session, I'll see you in the cafeteria, right? Also up here, I don't know if anybody has seen this, but I posted an extra midterm review. Classroom right here, and the answer key is right below it. What this is, it's I gave this to my ABs too, just to let you know your midterm review packet goes by Unit 1, Unit 2, Unit 3, all the way to Unit 6. This one is just kind of like random questions. Okay, so if you want to get exposure to some random questions and not the same type of questions over and over again, you can pick up this extra review there. Okay, and the answer key is right below it. The other thing I want to remind you about, don't forget about Unit 7, similar triangles. I know it's not in the review packet. It won't be in the extra reviews either because the AB midterm doesn't cover that. Don't forget about similar triangles. It is on the midterm. If you want practice, you go to your similar triangle packet and look in the back. Okay, don't forget, there's going to be a handful of questions dealing with similar triangles. Okay, so don't forget about it. Please don't forget about them. All right, so here's what I got for you today. I can get rid of this. Relationships and triangles are special points, some facts about sides and angles of a triangle, and then if we have time, I'll go over some constructions with you. So let's look at this first question right away, and this deals with all our special types of points of concurrency. So I want you to match up with the point of concurrency with what lines all intersect. All right, so let's start. Perpendicular bisectors. The intersection of the perpendicular bisectors is called that's the circumcenter right there. Yes, that is the circumcenter. How about the angle bisectors? That is called the incenter. The medians all intersect at a point called the centroid. Bless you, and there's one left here. The altitudes intersect at the orthocenter. Okay, so if I go in order here, it looks like I'm going to pick choice B. Okay, choice B. So knowing the names and how they're formed is great. And then we also have to understand what's so great about them, right? What's their special fact? Let's go to the second question below. Which diagram shows a point P that is equidistant from A, B, and C? Well, if I look at A, B, and C right now, those are the vertices of the triangle, right? Those are the vertices. So now we got to dig back to Unit 5. And what is that point that is equidistant from all three vertices of a triangle called? That is the circumcenter. So I am searching for the circumcenter. Well, I need a little bit more information. Yes, I'm looking for the circumcenter, but how am I going to find it? We can go back up top. That's going to be the intersection of my perpendicular bisectors. So now I need to search through my four choices. Which one am I showing you perpendicular bisectors here? Which diagram is showing you perpendicular, not just bisectors, both perpendicular bisectors. And that's going to be which figure up here? Choice A is my perpendicular bisectors. Let's go through all the others, though. Anybody know? Let's go to B. What am I showing you in B? The intersection of all the. So point P is the what? Incenter in this one. All right, let's go to C. Anybody know what I'm showing there? The intersection of the. Those are all altitudes, correct? So that would be my orthocenter. And then down here, what am I showing? The intersection of the medians, because medians go to opposite sides midpoint. So point P would be the centroid. Ooh, a lot on here, huh? A lot on here. Okay, questions? Yes, Jacob?
Orthocenter is the only point that can be outside of.
Not necessarily. Circumcenter can be. Because remember, perpendicular, like my diagram here, perpendicular bisectors do not have to come from a vertice. So if I draw all three perpendicular bisectors, it is possible that they will intersect outside the triangle. Centroid, in center, yes, always inside, always inside. Yep. All right, here we go. Next one, I got triangle ABC, of course. And point D is the centroid on median AM. So I need from vertex A to the opposite side. What is M on for BC then if this is a median? M is the what of BC? Midpoint, good. Medians are drawn to midpoints. And it says that D is the median. D is the centroid. So I'm just going to put a point D somewhere on that median. And this is going to use our centroid fact now. Keep labeling my diagram. AD is x plus 3 and DM 3x minus 6. All right, let's talk. What's the centroid rule?
Breaks it up into 2 to 1.
Okay, yep, 2 to 1, 2 to 1. That's what I do want you to remember, but I want you to know how to apply it now. 2 to 1 is great. What's the 2 to 1 actually telling you about this median AM? That AD is twice the length of DM. All right, again, the part that is always double is vertice to the centroid, is double the other part of the median. Okay, again, how do you know which one's the bigger piece? The bigger piece is always vertice to centroid. Okay, the bigger segment is always vertice to centroid. That is twice the length of the other piece of the median. So when I set this up, I just don't want to set them equal because they are not. We just said one piece is double the other. Fix it. What should I be doubling here? Oh, what should I be doubling? Not taking half of. What should I be doubling? 3x minus 6. This piece is equal to double the smaller piece. Or if you want to put the 1/2 plus 3, that's fine. You want to apply the 1/2 there. All right, let's solve because there's still another trap coming up. Let's see, what do I get there? 5x equals 15. X equals 3. Here's the trap. And I'm definitely going to do this to you on Tuesday. This is an honors level one. Oh, x equals 3. Pick me, pick me, pick me. Letter C, pick me. No, read. You got to take your time Tuesday. All right, take your time on the multiple choice. Those -2s are going to add up quick. Find AM. AM, not X. Not AD, not DM. The whole median, AM. Plug X back in. This piece is 6. This piece, of course, does come out to be 3. So my whole median AM is going to be a length of 9. Take your time. Take your time. All right? Questions? I'm on fire here. All right, next up, a little triangle inequality fact. I know 2 side lengths are 6 and 16. How can I figure out the other third side could be? Sum of 2 sides needs to be greater, not or equal to, greater than the third side. Sum of 2 sides needs to be greater than the third side. And what is the technique to find the possible lengths of the third side without listing them all out? Gage?
Add and subtract.
Add them, I get 22. Subtract them, I get 10. So my third side has to be somewhere between 10 and 22, not including them. Okay, not including them. Now, unfortunately, all my choices are not written like my compound inequality here. But if you break it apart, we're looking at which choice here? X has to be greater than 10, but less than 22. That's looking like choice D to me. Questions yet? All right, I'm going to blow your minds here in a minute. Not right now, though. All right, vocabulary time. Can you help me fill in the blanks? Some we've already talked about today, some we have not. What's the segment called whose endpoint is a vertex and it's drawn to the midpoint of the opposite side? That is a median. Yes, median. Hopefully this is opening up some eyes there. Tuesday's coming quick. All three lines meet at a point called the, just in general.
Point of
Oh, that's the perpendicular bisector. I'm just saying any three lines. Doesn't matter if they're medians, perpendicular bisectors, angle bisectors, or just three lines I don't know the name of. They all intersect at a point called the point of concurrency. All right, let's keep grinding away here. The what of a triangle is the perpendicular segment from the vertex to the opposite side. That's called an altitude. That is an altitude perpendicular to the opposite side. And the what is the point of concurrency for the angle bisectors. That would be at a in center. And I'll tell you straight up, hey, there's going to be a question on there that's going to say the intersection of these is called the what? Blank. You fill in the blank. Okay? So there will be a question like that on the midterm. Where it'll show up, who knows? Probably not in part 3, though, or part 4, right? The proof. All right, next up. Oh, I love this one. Find the slope of the median to BC. Okay? Find the slope of the median when I draw it to BC. All right, forget the slope part. Forget the slope. Can we talk about the median to BC? So it's got to come from A, agreed? And if it's a median, where's it going to go on BC? To its midpoint. So the first thing we need to figure out is what the heck's that midpoint right there? All right, everyone agree? Medians are drawn the midpoints. So I start from A and I draw it to the midpoint of BC. So we got to figure out that first. Midpoint of BC. I'm not even going to ask. We're going to know it by Tuesday, hopefully. -8 plus 6 divided by 2. And -6 plus 0 divided by 2. What's that? -2 divided by 2 and -6 divided by 2. So the midpoint of BC will be -1, -3. You will, I don't know if I've mentioned this or not, you will have scrap graph paper. I think 2 sheets of scrap graph paper attached to your midterm. If you want to rip them off at the beginning, feel free and use it. So this is a type of problem that maybe you want to graph it so you can do rise over run. We don't have that ability here, so we're going to have to go. So the slope of the median is going to be my change in y over change in x. I would love to do rise over run, but I can't here. All right, what are my y coordinates of the median? You have one of them given, the other one we just found.
8 and negative.
8 and -3. Order doesn't matter. -3 minus 8, sure. But now if you do not use rise over run, if you're going to choose to use this formula instead, now the order matters of the x's on the bottom. Everyone see how I took -3 first? So you have to take its x coordinate first, remember, on slope. Distance, it doesn't matter, but slope, it does. So now I need to start the x's, the difference in the x's with -1, and then subtract 0.
So slope should be 11.
So I end up with, what do we have here? -11 over,
-1, which then the negative is this lot, and it's just 11.
yep, slope of 11. Any questions there? I'm gonna actually add one to this now. I want to see how you respond to this. What if I asked, instead of the slope of the median, the slope of the altitude drawn to BC? Slope of the altitude to BC. So now it's not going to its midpoint, but what do I know about an altitude? It has to be Perpendicular to the opposite side. All right, let's start talking now. What am I going to need to find? And I know that's garbage, but just to give you an idea, altitude. What am I going to need to find here to find the slope of the altitude before I need to do this before I find the slope of the altitude? Sophie?
The slope of BC.
Yep. So why? Because these two slopes should be what of each other? Negative reciprocal. So if I find the slope of BC now, let's see, BC, what do I got there, kids? BC, -6 minus 0 and -8 minus 6. Change in y over change in x. So what's that? -6 over -14. You guys know I'm a big reducer, simplifier. 3/7. Okay, so the slope of BC is 3/7, which would make the slope of my altitude the negative reciprocal because they're perpendicular, -7/3. Just wanted to throw that at you too. Whew, how you feeling, huh? How we feeling? Doing all right?
Yep.
Okay, I got another. I don't want you to forget about these. I said find the number of sides of an equiangular. We use the term regular. All sides, all angles are the same. All right, equiangular polygon if each interior is 170. And I hate to break it to you, I wouldn't guess and check. Let me try 5 sides. Let me try 13 sides. You could be there for a while, probably past the 2-hour mark. All right, probably past the 2-hour mark. Each interior angle is 70. Don't care. Don't care. What I like to deal with, if the interior angle is 170, I like to deal with the exteriors instead. And I'll show you why. How do you find the exterior here? Ooh, hold on. Just the exterior. How do you find one? Not the sum of them. One exterior. Theo. Good. So that gives me one exterior of this polygon is 10 degrees. Why in the world does Mr. Carlino love to deal with exterior angles? I already know what they add up to. They add up to 360. So now I can take the number of sides. That'll be equal to 360 divided by one of those exteriors. And then that tells me I have a 36-sided figure. Good luck guessing and checking that. Okay. So deal with the exterior if you can, please, because you already know it doesn't matter the number of sides. It's always going to add up to 360. Here, I'm not really too sure what all the interiors add up to because it's always different depending on the number of sides. Questions there? All right, I got one more. This has nothing to do, well, it kind of does with triangles, I guess. Just a quick review. Don't disregard that. Get that out of there. All right, find x. This is a rectangle. And the 40, just so everybody knows, there's no confusion, the 40 is referring to that angle right there. That's 40. I just wanted to bring up a reminder of one of the properties of a rectangle that's usually forgotten about. I'll direct this one. Can you find the angle next to 40? The linear pair next to 40? That's going to be 140, correct. All right, here's the property I don't want you to forget about with the rectangle. Diagonals are congruent and they bisect each other. Diagonals are congruent and they bisect each other. That's not the two properties. I'm pretty positive you'll remember those. But because they're congruent and bisect each other, that makes all 4 of these congruent and forms how many? 4 what type of triangles? And what's across from those congruent sides? That's how I get to x. Okay, that's how I get to x is I take 180 minus the 140 I already have, and I now know since that's isosceles, those two angles have to be equal. Divide that bad boy by 2, and x is going to be, what's that, 40 divided by 2, 20 degrees. Okay, so just that little property that might help you out on a problem. That the diagonals form 4 isosceles triangles. Not congruent to each other, but 4 isosceles triangles. All right, anything? All right, next up, you got your packet, construction packet. You can close up your Chromebooks, we're good there. You got your construction packet on you. something happened to me over the course of the week. I don't know what it was. I don't know if I woke up with it or what. But some of the ice has chipped off my heart. Okay? Just a little bit. Just a little bit. And I said to myself one day this week, I was like, you know what? These honors kids, even though they're honors, and I hold them to a high expectations, they work their tail off. But I know many of you in this class, many of the 24 of you I have, will work your tail off to prepare for this exam. All right? And to show my gratitude back, here's one little thing that I'm going to do for you. We have a whole bunch of constructions we've done this year, huh? Instead of just feeding you to the wolves and saying, good luck, one of those will be on there, I'm going to narrow it down for you. Okay, I'm going to narrow it down. I have selected, I think, 4 different constructions here that I want you to focus on. Okay, that I want you to focus on between now and Tuesday. 1, 2, 3, yep, 4 different constructions I want you to focus on. The rest, don't worry about them until we get to the regents, and then we do have to worry about all of them because I don't know which one it'll be. Right? And I also want to see who's going to take advantage of this. Right? A true honors level student to me is, whoa, he's given us a little inside look into the midterm. I'm going to take full advantage of it and get that question right without a doubt when that construction comes up. All right, let's talk about the first one. It might be a perpendicular bisector. So please find that. I don't know where it is in your packet. Please find that in your packet and let us talk about how to do a perpendicular bisector. This is one of the first ones I've shown you. I take my compass, put it on one of the endpoints. We open our compass up more than half the length of that line segment. We are drawing a perpendicular bisector for. And we want about a half circle size arc here. All right, a half circle size arc. Boom. I keep the same opening of my compass and I travel over to the other endpoint. And when doing this construction, do you remember how many points of intersection I want on these arcs? 2, because you need something to line your straight edge up with. 2. Yes. And then I do line up my straight edge and boom, we draw it through. All right, I'm not going to go over all 4 of them I have there because we don't have time for that, and you can do that to practice. But I do want you to make a couple notes. On the midterm, the construction might not be perpendicular bisector, but it might be something that needs the perpendicular bisector. So I want to talk. Where else and what other terms could I use perpendicular bisector for? Well, let's say I had a triangle, and you drew in all 3 perpendicular bisectors. What point did you just find? Yep. So we could also use this for a circumcenter construction. So maybe on the midterm, I say, here's triangle ABC, find the circumcenter. That's not a new construction. That's this. Okay? That's this. There's more, though. There's more. When I draw in a perpendicular bisector, it intersects the what here of this segment, AB? Midpoint. What can I draw to midpoints in a triangle? Medians. This is the same construction you would do for a median. You do your perpendicular bisector, and then wherever the opposite vertex is, you connect it. Whoa, medians, you say? So if I drew all 3 medians in a triangle, what did I just locate? Centroid. Oh, so this is the same exact one for a centroid. Yeah. So even though I may ask for one of those 3 down below, I'm asking for a perpendicular bisector. Everyone good? And those are the 3 right there. Questions? So maybe it's a perpendicular bisector straight up. Probably not. Or I may ask for one of those 3 down below. Okay? Everyone good? All right, well, what if it's not that or any of those? Well, we now have an angle bisector I could ask for. All right, so please make sure you find angle bisector. When you're ready, put your compass point on vertex A of angle 1. And make an arc through both rays of that angle. I know it's been a while since we've done constructions. My recommendation, use small arcs. I found when I started teaching these to you guys in the fall, kids struggled when they made these huge arcs because they never knew what intersected with what. Try to keep it to small arcs, please, if you can. All right, mark the 2 points of intersection, please. From here, you can now open or close your compass, smaller or wider, whatever you need. But the next 2 arcs we make have to be the same opening. Okay, these next 2 arcs we make, and they're going to come from each point of intersection. They have to come from the same opening. If you want to have the same opening for all 3 arcs, that's fine too. It'll still work. We make an arc. And we go to the other point of intersection and make a second arc. Make sure the last 2 intersect each other. We do not care if it intersects the first or not. The first arc is drawn so you can get points of intersection. That's it. And then once you have the little fireworks going, you can line up your straight edge, throw in your angle bisector. I could do an angle bisector. I could ask you for something else that would still be the same construction. What if we did all 3 of these in a triangle? I could also ask for in center, and this would be the same construction. And that's it. There's nothing else we can use angle bisector for. Everyone good? Perpendicular bisector and its uses. Angle bisector and its uses. Possible construction option number 3. Go to parallel lines for me. I could ask you to construct a set of parallel lines. Whew. This one was a beast. Here's what I would give you if I asked to construct parallel lines. I would give you a line to make it parallel with and a point that the parallel line has to go through. First step, you need a transversal through both. A decent sized transversal through both. So you take your straight edge, decent size. Whoa, what is that? Jesus. One job. Let's try that again. Going at any angle. All right, doesn't matter. Going at any angle. That angle bisector construction we just did is going to be used here. Here's what I'm about to do. Let me show you my plan before I execute it. I am going to copy that angle right there onto that ray. All right, copy and actually it's not angle bisector. Sorry, it's copy and angle. All right, I'm going to copy that angle onto that ray. First step, everyone put your compass point on the vertex you're about to copy. Again, remember, small arcs if you can. Make an arc through that angle you're copying. Head up to point X, the end point of the ray we're going to copy it onto. And go ahead, make an arc. Boom. So that's all I have right now. Again, gigantic arcs aren't going to help too much here. I like to keep them separate. Go down, go back to the angle you're copying. Everybody made 2 points of intersection, right? Just open up your compass to those 2 points. You do not need to make any markings here. Just open up your compass to those 2 points for me. Everyone's got them open to those 2 points. All right, here's what you have to remember now. The final step is not going back to the end point. It's going back to where it intersected the ray. So head up right now, go past X, head up to the point of intersection there. And you want to make sure it intersects on the same side as the angle you are copying. And hopefully it lines up with X and is going to look parallel to M. All right, there we go. Thank you very much.
You're welcome, man.
Have a good weekend.
Yeah, you too.
No, I'm just showing you the difference between the two up here. That's it. I don't need a dotted line. All right, parallel lines. All good? Again, I don't have time, sorry guys, to go around, but if you're coming to the review session, I'll certainly sit down and go over whatever you need. And then, or after school today. And finally, the fourth option it could be perpendicular line that it's not on the line. Okay, let's take a look here. So I need a perpendicular line going through P and perpendicular to M. Get ready to smile, or Sophie?
Is there nothing else that parallel lines can be used?
No. No. I'm just going to say, here's a line, here's a point, draw a line parallel through it. There's nothing else I'm going to do fancy. Get ready to smile or frown, because that's what we got to do here. Put your compass point on P. Open up your compass so that you can make an arc that intersects in two spots. If for whatever reason you can't get it to intersect in two spots, always extend your line. Lines go on forever, so extend it. There it is. That arc establishes points of intersection. That's what your first arc is for. Establishes points of intersection. From here, personally, it doesn't have to be, but personally, I always like to open it up just a smidge wider. Because here's what might happen. If this happens, where the point of intersection lands right on P, you needed to open up your compass a little wider after this first arc, okay? So that's what I like to do. Sometimes, though, you can get away with just keeping it the same for all three. Go to each point of intersection now. Make an arc. You can do this above or below. Doesn't matter. You can do this above or below. Keep it the same opening as you travel and do your final arc. And again, those last two arcs should, perfect, intersect each other. And there it is. I could use this construction for something else. Maybe if I do this, it'll help you. Altitude, correct. This is the same construction as an altitude. The point is a vertice and drawn perpendicular to the opposite side. The line is the opposite side. So I could ask for an altitude and it's still the same construction. Oh, whoa. One more, actually. If I can ask for altitude, I can ask for orthocenter, where all three of them intersect in a triangle. So there you go. A little narrowing it down. Last thing I just want to remind you, and also it's a reminder and a warning. When you're on Classroom, very first thing, I've kept it up top for the entire year. These are all how-to videos. So if you need a reminder on how to do any of those 4 constructions that might be on the midterm, you can go there and find what you need. But a warning, Monday, district says bye-bye to YouTube on your Chromebooks. Okay, I think they sent something out a week or 2 ago. So if you need access to it, you're going to need either your phone or a different device because these are all YouTube videos and I can't transfer all of them over to Classroom. All right, and that's not going to happen yet anyway. Okay, so just a heads up. What?
Or screen record them onto your Google Drive.
Do you know how many videos are here?
Just the ones you need.
No, you guys aren't that important. All right, sorry. That might be a summer project, but. So just a heads up, if you're doing this on your Chromebook, I believe starting Monday, I don't know if that's true or not, but that's what they say. Starting Monday, you won't have access on your Chromebooks anyway. You can access it still on any other device, but not your school-issued Chromebooks. Okay, guys, we have, 6 minutes left here? Is there anything you want to throw by me? All right, I packed a ton into these 3 days. That's why we only need 3 days. If you want to look back at the videos from the last 3 days, I would maybe recommend that to see what questions and types of the topics we went over. Again, you only have access to those until Monday. You got to watch them on something else on Monday. Zach, go ahead.
The statement reasons proof can be any proof.
Correct. So you want me to list a couple off here? Proving triangles congruent. CPCTC. Proving triangles similar. CSSTP. Product of the means equals product of the extremes. Quadrilateral, right? This is a parallelogram. Prove these triangles are congruent. Prove these angles or sides are congruent by CPCTC. So you got to know your quadrilateral facts. Or it could be an indirect.
No parallel line proofs though. Probably not a parallel line.
No, I'm going to go more hardcore than that. Yeah, I'm going to go beyond Unit 3. So this is definitely something from Unit 4 through 7. Yep. Prove a pair of triangles to get another pair congruent. Okay. And remember too, I believe I assigned a couple proofs during the week and did I don't know if I did any with you, but I definitely suggested a couple. There's a reason why I suggested them. All right. Sophie.
For coordinate proofs, if you have to prove a like rectangle,
Yep.
is it only one like 190-degree angle?
After you show it's a parallelogram.
Yeah.
So you have to show it's a parallelogram by whatever method. Opposite sides congruent, opposite sides parallel, and then you have to show one right angle exists. Not all 4. Yep. And then my discussion just with Zach, notice I didn't say coordinate proof. That's not a statement's reasons. That could be in part 3. Could be in part 3. Violet.
Proving a rhombus.
Yep. Are we talking coordinate proof?
Yeah.
Yep. Coordinate proof proving a rhombus. I would just do all 4 sides equal. You don't need to say it's a parallelogram. Okay. Notice how I didn't just say forget about it to those 2 questions as well. All right. If somebody asked me a square, I would have said forget about it. And also, too, don't focus on quadrilaterals. I may ask, prove this is an equilateral triangle. Prove it's isosceles. Be prepared for that. It might not just be a quadrilateral coordinate proof. Just throwing options out. Go ahead, Tess.
There's a data in the proving triangles congruent unit that there was really hard ones.
Yeah.
Is it the difficulty in the packet or could it be?
They're in there. If you look at Unit 4, I put some of those in there. And you're talking about where you need 2 triangles congruent, but I only gave you 2 out of 3 parts, and you're like, where is that third angle? Where is that third side? Where you have to prove another pair to see what they have in common. Yes, that is a definite possibility for the statement's reasons proof. Okay, and that's all in Unit 4 of your packet.
Will HL be an option?
It could be in the multiple choice options. Sure. All 5 are options. Yep. Anything else you want to run by me? I guess the last thing I'll say then is just, hey, good luck. I know you guys have other midterms. I don't know how many, but good luck on those, including ours. And we'll see what you can do. Please don't be afraid to email me with any questions or Delta maths that you want. I'll respond back. Don't worry.
Mr. Carlin.
Yep.
if I'm bored during the week, then I might lock in and do a screen record as many